We're back with a A-level question, and this time we are doing a question from June 2019, paper 1, question 5. And to prove how old I am or not am, that is the exact paper I sat. So we have a function, we have this, a sketch, and transformations. So a whole host of things here. It's actually not a bad question. Very easy to overcomplicate. The reason why I picked this question out is for this part here. This is hard. That is GCSE. That is GCSE. That is to some extent GCSE knowledge with A-level application. So let's just get to it. There are two ways to complete the square. I do expect you to know one of them, and that's just depending on how you're taught. The two ways is you can either take 2 out all 3 terms, or you can take 2 out the first 2 terms. I'm going to take out the first 2 terms because if I take out all 3, I have to write 4.5 or 9 over 2. I don't want to deal with a decimal and I don't want to deal with a fraction. So let's start. We take 2 out. We use square brackets. Very important. Even when you're integrating, square brackets are important. Make the use of correct brackets. We are left with x squared plus 2x plus 9. We then complete the square of the square brackets. Yes, I'm saying square a lot, I hear it. And then we expand. Internal monologue is telling me not to say expand the square brackets. And we are finally left with our answer of x plus 1 squared plus 7. Cool, done. Part B, sketch y equals f of x. The exact question does say labeled with intercepts, etc., though that should be a given by this point. We need the turning point. You should be able to recognize the turning point that you can get from here, which is -1 and 7. You should be able to recognize the y-intercept from there. The plus c value is 0, 9. So 0, 9, -1, 7. Do you need to calculate the roots? No. It is a positive x squared graph. It has a minimum value above the x-axis, meaning it will look like that. You can put in your calculators. It will say math error, or it will say imaginary numbers, etc. So use a little bit of intuition and you'll be fine. That's part A done, that's part B done, and just before I forget, everything is now labeled. And now part C, describe the transformation. This one is pretty annoying because obviously, well, let's start it. This was part A and this was part B. This x minus 2. This minus 2 isn't here. So we want to say it's a translation. And then the column vector. -2 means it's going to move 2 to the right in the x-axis. And then we kind of look at it and the go-to would be, oh, okay, it's moved, 12 down? But this is where you have to have a keen eye. When you expand this, and let's get color number 4 out for this. So we're just focusing on the -2 squared part. The -2 squared multiplies by that 2 to give you 2 times 4 gives you 8. Then when you do the 8 minus 3 from here, the actual y-intercept of g over x or the plus c value of g over x is actually 5 in comparison to 9, which shows a translation of 4 down in the y-axis. So that's -4. So some of you might think that was tedious and easy, but it is very easy to be caught out on it, especially when it's so early on in the paper and you're thinking everything is going to be easy and they kind of throw in something a little bit more hidden. And now we have find the range of h of x. Nobody likes range and domain at A level. It doesn't get explained awfully well because a lot of it is assumed knowledge. So what do you see? Giving you a moment, I'll tell you what I see. And this is a leap, and this is why the leap kind of came in at first year of university for me, because this is when they started explaining things a little bit clearer. But that's why I'm here. I'm going to try to help you see it the way I see it. This 21 doesn't matter. It's just a constant. A. We know this denominator is a polynomial. It's a quadratic. Do we care the stretch of the polynomial? No. Do we care about the width of the polynomial? No. We just care that it is a quadratic polynomial, therefore x squared. And if I draw this, it looks like that, which means it has an asymptote at x equals 0. Therefore, this graph has a range where, I'm going to change this of h of x so it doesn't confuse us, to, we're going to use m. The reason I don't use I and j is because they're useful vector notation. So m of x is a over x squared, and it has a range such that m of x must be greater than 0. So that same principle can be applied to h of x. H of x must be greater than 0. Now, we have confirmed a minimum value. We now need to check for an upper value, because it is slightly different. It's not just x squared. There might be limits to it, and we know there are due to part B. I can rewrite h of x in the form of 21 over, and then the completed square form. And what you should see here is, we know a big number, or any number divided by the smallest possible number is going to give us the maximum value. So 20, if the graph only goes down to 7, and we do 21 divided by 7, which gives us 3, that is the maximum the graph can reach to, because we're dividing by it. Therefore, this is the upper limit of the graph. So we can finally write our full answer of 0 being less than h of x, which is less than or equal to 3. It was a lot to see. I am happy to explain range of domain in a little bit more detail in another video if you wish. So let me know in the comments, and let me know how you did on this question.